Module 4, Objective 10, relate the types of muscle fibers to muscle performance and discuss hypertrophy and atrophy. There are three types of skeletal muscle fibers in the body: fast fibers, slow fibers, and intermediate fibers. Fast fibers are the majority of our skeletal muscle fibers, and they contract very quickly. They have a very large diameter, they have large glycogen reserves, very few mitochondria, and they produce strong contractions, but they fatigue quickly. And if we think about this, strong contractions would be associated with the very large diameter. They would have a lot more room for the myofibrils. And fatigue quickly is associated with having few mitochondria, so the cell cannot generate large amounts of ATP, so they're not going to be able to sustain muscle contraction for a long period of time. Slow fibers are slow to contract and slow to fatigue, and part of the reason they're slow to fatigue is the number of mitochondria that they have. They have a lot of mitochondria. They also have a high oxygen supply from an extensive capillary network, as well as they contain a protein called myoglobin, which is related to hemoglobin, and it can bind extra oxygen. So it even has more oxygen sort of backup for aerobic metabolism. Otherwise, they're slow to contract, very slow to fatigue, very small diametered. Here we see some differences in slow and fast fibers, and again, really the only thing you could make out would be the size. So fast fibers are a lot larger, while slow fibers tend to be smaller. Intermediate fibers are intermediate. They have a little myoglobin. They're slower to fatigue than fast fibers, but they're not so much compared to the slow. So they're intermediate. Muscle performance is somewhat related to the distribution of these muscle fibers within our muscles. If you think about fast fibers, these are very strong fibers due to their large size, but they're very quick to fatigue. And this gave rise to the concept of white meat. If you think about a chicken breast, it is white meat because it's mainly composed of fast fibers. So if you think about the evolution of the chicken and what it uses its breast meat for, it's mainly for flight. And chickens are not flyers. They use flight only to get away, just in short bursts of energy to get away from a predator. So that is where the whole concept of white meat or white muscle comes from. Red muscles, or red meat, we call dark meat, are predominantly slow fibers. If you think about the thigh or the legs of a chicken, these are muscles that have a tremendous amount of slow fibers, and the color, the dark color, or the red color, is really associated with the myoglobin, the fact that it has this ability, this protein that stores excess oxygen. For humans, our muscles contain a mixture of fiber types. We do not have white meat and dark meat muscles within our bodies. Everything is just pink, so we're intermediate. Muscle hypertrophy is a growth of the muscle, and we can increase the size of our muscle through heavy training, and that's going to cause changes in the diameter of the muscle fibers, the number of myofibrils that are present within the muscle fibers. We can increase the number of mitochondria so that we can increase our endurance by providing aerobic metabolism for muscles to generate ATP, and we can also increase the glycogen reserves. So through weight training, as one is trying to increase their muscle mass, this is what is increasing: just the diameter of the fibers, the number of myofibrils, i.e. the number of proteins that are involved, the number of mitochondria, and the glycogen reserves. Muscular atrophy is a reduction of muscle size tone and power due mainly to a lack of activity. And again, I think we've all experienced individuals who have had limbs casted and how much muscular atrophy occurs. As we age, skeletal muscle fibers become smaller in diameter and they become less elastic. In fact, they can become fibrotic, and fibrosis is an increase in the fiber's connective tissue. Sometimes muscles can even be replaced by connective tissue, which decreases the contractility of the muscle. We also lose a tolerance for exercise and the ability to recover from injuries. Muscle fatigue: when a muscle can no longer perform at a required level, they are fatigued, and that's correlated often with the depletion of the metabolic reserves. You can have damage to the sarcolemma or the sarcoplasmic reticulum, due partly in the decrease in pH due to the lactic acid buildup. The decline in pH can affect calcium ion binding, as well as altering the activities of the enzymes, and just overall weariness due to ultimately the low blood pH and the pain associated with the lactic acid buildup.